Good morning, everyone. My name is Kushakang and my supervisor is Dr. Noor Hidayah binti Zanan, and we are from University Technology Malaysia. So today, I will giving a presentation about the topic biotemplate silicon nanowires for next gen chips. Then how this research proposal can relate to SDG 9 and 12. To related to SDG 9, this proposal is looking from the smarter industry scope. Like this proposal is use the biotech instead of high heat with the toxic metals. So this waste is more cleaner and then can is more cheaper for the chip making. And then for the innovation scope is combine biologic with the nanotech together is a brand new way to grow the semicon. And then for the SDG 12 is looking from the energy saving part because this can works at room temperature vs with the 1000 degree which is using the traditional ways. So this way is lower energy use and then more or less carbon dioxide emission. So for the introduction part, actually the semiconductor industry needs better greener way to make the chips. So normally the old method is use the gold with the very high heat at the range 400 until 1000 degrees Celsius. And then this method is actually very expensive, polluting, and not sustainable. So what's our idea is use the genetically engineered bacteria that can grow the silicon nanowires at room temperature. And then our methodology part can separate to 5 steps. So the first step is the genetic engineering strategy. So we plan to put the sponge gens into the E. coli. And then this enzyme help the bacteria grow the silica. And then the bacteria display silicatin on their surface, means ready for the nanowire grow. So for the second steps is the expression system optimization. And then the temperature is at the range 18 until 25 degrees Celsius to keep the enzymes very active. So the PTG is zero point 0.1 until 1 millimolars. This range is not too much but not also too little. So for the time is 12 until 24 hours. And then this time is enough to make the proteins and then not toxic. So for the third is the biosilification process. The silicatin show up the bacteria surface, then add the silicon salts together also. So the silicatin can turn into the silica shells. And at that time, the bacteria act as templates, means keep their shape. So for the fourth steps is the magnesiothermal reduction. The heat is put at the range 605 until the 850 degrees Celsius mixed with the magnesium so that the silica can turn into the silicon nanowires, and then we will use the acid wash cleans leftover the magnesium oxide. So for the last steps of the methodology is the nanowire properties. So the properties is very thin at the range 20 until 100 nanometer, and then the long of the wire is at the ratio 100 to the ratio 1 aspect ratio. So I would like to talk about is the recommendation part. So for the recommendation part, this actually can improve the genes, make the enzymes more efficiency and stable, and then more bigger reactors. Like for you can use for the industrial scale production. And then for the device integration is test in real chips transistor. Then for the material improvement is to control the electrical properties with metabolic engineering. Then for the discussion part, I would like to talk about is the technical performance. This can work well for transistor, like you can get a great switching performance. Then the natural doping from bacterial DNA is not extra step needed. So we looking from the environmental impact is the we are using the room temperature to grow it. So which means is use the less energy and then the less waste compared to the traditional methods because we didn't use the gold. And then this actually also supports the circular economy, means we can use the waste to make into the valuable materials. And then for the conclusion part, I would like to conclude that the biotemplate silicon nanowires is represent the future of the green chips because these methods use the bacteria instead of the using the gold, which means uh, it is compared to the old methods lah. And then this methods is save more energy because just using the room temperature, and then also produce less waste. Okay, that's all from me. Thank you.